Okay, so let me just put this back on, because I just quickly retested the wires. So what I've done is, those 3 dead ones, and the rest are all 8. Oh, hang on. Yeah, the problem is obviously it might be a wiring issue, so I'm not really worried. I just want to confirm that the ones that I've got in here are the ones that actually have the reasonable volt. Now, the actual voltage that these are at is irrelevant, essentially. I just need to make sure that the voltage that they're at is around the original charge voltage. I mean, if I set that at 8 volts, I expect them to all be around about 8 volts. If I set that to 8.5, I expect them to all be around 8.5. They've got to be at a similar... It depends on the chemistry. Obviously, I can't set that to 100 volts and expect them to be 100 volts. But I expect them... The voltage... Essentially, the voltage of each one. I think the actual charge voltage of each cell, because there's 6 in them, is 1.5 volts. Okay, but it's not. What you do is you put in a higher voltage and you keep the current constant, you see. And then eventually when it gets up to a certain level, you then say, right, okay, that's it, I'm charged. And in these cases, I'm pretty sure it's a nickel metal hydride battery, okay, with 6 cells in it. And I think that the level at which you stop charging is 1.5 volts. Now, 6 of them, so that's 9 volts. So you'd normally charge it to 9 volts. So the level I've charged it to, which is 8.25 volts, which is essentially an arbitrary voltage, right, is not the full charge level. Now, that's deliberate because I don't want them, because when they go in the pack, that's the sort of voltage they keep. It keeps them roughly at that voltage. Okay. Because it's not aiming to fully charge anything. It's aiming to maintain roughly half charge, because then that means that these batteries last a long time. That's the whole point, you know. So currently I'm charging them to the same sort of level, 8.25 volts. You know, it's just arbitrary, right? And they're all maintaining that, which means their voltage is fine. The next test is okay, the controller will recognize the voltage. It can't measure it can measure the current, but it can't measure it. And what I need to do now is then check it against that. But what I can do is basically put the battery into the car, and it has a register of how much current it draws when it's starting the engine, which is the biggest load. Okay, I think. Well, no, when you're actually powering the car and driving it. But I'm talking about here, whilst the car is down there in the workshop, the representative load is going to be when it starts the engine, because that's when it's actually powering the motor to spin the crankshaft of the engine, and then the engine fires and takes over and starts the generator. So this is how it works. So what I can do is I can actually make it start the engine and find out what current it draws in order to start the engine. I know it's going to be something around about, I'm guessing, because when you actually start a car with an actual starter motor, the starter motor is usually it's drawing in the region of 500 amps and it's 12 volts, right? So a rough calculation, 10 times 500 is 5 kilowatts. So I'm expecting it to take sort of in the region of 5 kilowatts, right? Now the entire battery is around about, and I'm not going to use exact figures, but it's around about 200 volts. I'm pretty sure that the voltage is about 200 volts. I think it's 201 point something, right? So 5,000 watts divided by 200 is that's 5,000. That'd be 500. That'd be 50, and then divided by 2 is 25. So the actual current draw, I'm guessing, and this is a complete guess, is going to be in the region of 25 amps. Okay. Now I can draw 50 amps by putting a big thick wire around it and putting my clamp on it and seeing what the draw at 50 amps is, just to get some sort of representative power. Now when it's actually pulling, you know, like when you've got your foot down and you're actually powering the car, then the output from the battery will probably be pretty high, and we're talking about it's actually, I think it's roughly the same power as the engine, which is I think the engines in this car is sort of 80 horsepower, somewhere in the 80 horsepower, but let's just say for round figures it's 50 kilowatts, which is I think 88 horsepower. So let's just say it's drawing 50 kilowatts, right? Now I just did a calculation, a rough calculation for 5 kilowatts, the starting power, right? Which means that when it's actually running and powering the car, I'm thinking we're talking about in the region of, because I said 25 amps for that, so I think it's in the region of 250 amps. I don't know, but I've got a feeling that it's actually capped at 100 amps, right? So we can, for instance, test it drawing 100 amps from one pack, because it's 100 amps from all the packs, and that's where we need to see what voltage it drops. Now it will drop. You're drawing 100 amps from this pack, right, through that terminal there. Then yes, it's going to, and it's probably going to get warm as well, you know. So if I was to, but I would say that a representative current draw is going to be, you know, in the region of sort of 10 to 50 amps, maybe 100 amps, yeah. And we can see what but I don't know what the voltage will drop to, you see. So that's why I'm just using a low one, because the idea is that if it drops under a low draw, then it's fucked, isn't it? And I'm talking about drops like as in a volt or something. Do you know what I mean? For it to drop like, you know, a few millivolts isn't a big deal, right? Because it will do, right? But if it's dropping like in the region of a volt, or probably over 100 millivolts, if you're only drawing like less than an amp and it's dropping, you know, 0.1 volts, then you've got a problem. Yeah. If it's dropping, say, 10 millivolts, yeah, I would even say you know, even 10 millivolts I think would be an issue with that sort of current draw. But what you're doing is you're getting a representative idea of how it drops under a very small load compared to what it normally is. And if it drops at all in any significant way, I would say that if it drops 10 millivolts with that load, given what I've seen, then I think it's got a problem. But we'll do it, you know. In fact, I can probably do it now. Yeah, so let me stop.